Welcome aboard to another episode. In this episode we're going to have a look at my old router. I used this for I think 5 years in business making parts for sale, and I had no major issues with it, but it's a fairly poor piece of construction work. The design was okay, but they didn't execute it very well. I think it was made by Messrs Slap and Dash, but we'll have a look at it and see what you think. This is quite a long video, but I think it's worth doing because hopefully it'll point out some of the pitfalls to other people. If you buy one of these things second hand, or even buy one new, just have a look and make sure that it's as well made as you think it is. So roll the titles and we'll carry on. So here is the old router. I think the first thing to do, because it's been sat stationary for 2 years, is to get the dust off. Don't have a blowgun, but this does the job just as well. This machine I bought when I bought another group of laser cutters, and there's one laser cutter left there, just that blue thing you can see here. Let's go down here. I've kept one laser cutter from my old business, and also I kept this, the CNC router, and I made a couple of mods to it, and I'll just I did this in a previous video, but I'll just show you again. The stepper motors. This drives the x-axis, y-axis, sorry. They got unbelievably hot when it was running. So I had this, an old HP server kicking around, and it had some nice passive heat sinks on it. So I made these little adapter plates that you can fit these heat sinks to the, they just clamped on to either side of the stepper motor, and that made a massive difference. It kept them cool. This Z-height in particular got so damned hot. Let me just try focus again. There we go. That got so damned hot you couldn't actually touch it. So just putting this single little heatsink on has made a terrific difference. And there's the other axis. Let's come round where the sun's not in it. There you go. You can see there's 2 heatsinks bolted or clamped either side of the stepper motor. That made a, like I said, that made a massive difference. The other thing that I did was, between the control cabinet and here was about, and the deck was about 80 odd volts AC. It's enough to make your fingers tingle. So when I investigated it, this was not earthed to the electrical cabinet. So I added this little Eddystone box, a die-cast box, and put, I don't know if you can see that particularly well, but put a decent earth cable all the way through the loom to this end. Here we go. That earths it to the cabinet. The other thing that I modified was, and these are just getting a bit rusty now. I need to take these off and clean them, but I made these caps, and they're hollow inside, and I'll show you in due course, but because this needs to come off to be cleaned and repainted, I think. The end of the drive shaft, that's not the word we use for it, is it? What are they called? Ball screw. The end of the ball screw was completely open here. There was nothing to mitigate dust and crap getting into it. So so I made these little caps that fit over the top just to protect the bearings, to be perfectly honest. And I needed 2, and there's the other one at the front of the machine. Before I can test this, plug it all together and test it, I need to just lift it up, because the y-axis ball screw is held from rotating by a vice grip. Because when I stored this in the garage, I'll drop a picture in, the head had to be at the top rather than at the floor level, because it would have been in the way of the car, I put a vice grip on an unused portion of the ball screw, so I need to lift this end up and get that off. With my first car, I managed to get my hand caught in the suspension when I was working on it one day, and I also did a short spell in the oil industry, a very short spell thankfully, and a young lad on his first trip out had got his hand under a load being winched off a supply boat, and crushed it to the point where it would probably never work again. So I've always been, from that point on, very careful to make sure that heavy weights have something to land on without crushing me. Please do the same. Life is so much easier with the right bits of kit. Okay, let me get the control cabinet back and we will plumb her up. Anything's heavy. There we go. I do like these locking connectors, they're really good. Each one is marked, so not well, but it is marked. The pendant comes through and goes straight into, I think it's upside down. There we go, goes straight into the end of the control PC. Let's turn her on and see if anything lights up. That's promising. It's asking me to home all axis. Before I press that, I'll move the camera so you can see that that power supply is running, that power supply is running, the VFD for the spindle's running, the 3-stepper motors are running, the only and this must be running because it's asking me if it would like to home the axes, so that's all looking quite good. Just press the green button for axis all home and see if it works. But hey! Okay, we have a fault. There's a limit switch under here and it's trapped, so I need to release it and try and reposition it. This whole thing doesn't look good, does it? That's fairly crappy. I think I better turn off, jack this thing up and fix that. That's not good enough. The brackets look secure mostly. Let's get this cover off and have a look. I think I might put some bolts in there. And probably the same at the other end. That should help secure it. That's the thing with living on the edge of a military training area. You just heard a Gazelle helicopter going over at about 150 feet. Right, I think I might replace the 2 screws in here as well. Right, I made my little bracket up and I thought I'll just take this off. This is really mangled and you probably can't see it, but when they built this they actually missed with the where the threaded holes were supposed to be and had 2 attempts at it. So I think what I'm going to do is take this whole thing off and take it up to the old workshop and panel beat these brackets straight again, and then reassemble it. And this was the clincher for me to do that. This is the proximity sensor for the end stop. It I'll pull enough through. It basically picks up the edge of this aluminium casting, but it's straight through a hole here. There's a massive burr on the back of it. As vibration will, in fact, there is some damage on the cable as it is. You can see where it's started to be cut through. You can feel the cuts in the side of that sensor cable. So there's no way of getting it out short of cutting the cable. So I'll cut the cable and take this whole tray off. Right, that's my sensor. Right, let's go and see what we can do with that. Ooh. Right, I've just taken it to pieces, and you can see just how mangled this bracket is. So I'm going to see if I can straighten it, and if I can't, I'll have to make another one. While I'm here, I'll show you the other end. I don't know if you can see that, but that's a razor sharp burr where the sensor cable went through. So that needs to be addressed as well. Oops. Whilst I've got this this cable tray off, I'm going to mount the end of it properly. That was really badly done. Also, the harness, the wiring loom, went out the end and was clamped in there like so. And now this is going on a desk. It would make more sense for it to go straight down and straight through the desk. So I'll mark up roughly where I want to put the hole, and I'll drill a hole big enough to get this whole thing through, and then come up with a method of clamping it in place. Blimey, for a guess that's not too bad. Hang on. That's close enough to file. Ow! What we're looking for is clearance here so that the sensor underneath actually picks this up but doesn't get mutilated in the process. There we go. Job's a good one. Yep. And the little sealing ring. Oh my word, that needs a clean. Oh my word, does that need a clean. Oh dear. Oh my word, look at that. I've plumbed it up to the router spindle and put 3 litres of water in it, so let's turn it on and see if it still works. Fan works, 21 degrees, that's about right. It's the little pump, and yeah, the output of the pump goes through this, which is a flow switch, then out to the spindle. Back from the spindle it comes back in and goes through these 2 coils, and the fan, the back here, blows air over those coils, so it'll only ever chill it down to ambient room temperature, but yeah, it's good enough. One thing I will just say is this flow switch is there to tell you if you've got a problem, so if I keep the line feeding out to the spindle motor, then it'll raise an alarm. There you go. Release it, it goes back. And on this particular one, because this router, occasionally this has difficulty pushing the water through. If it gets low level or whatever, then it can trigger a false alarm. So what I did was put this little switch in that turns the buzzer off. So if I kink it now, I think that's the way I'll run it for now, just and see how I go, to be perfectly honest. But we did find that we needed that switch to turn off the buzzer, because like I say, it false triggered several times. Right, no leaks the following day, so I think I can put the cover back on. Right, fin. just before I decommissioned this machine and put it into storage, I was getting some ticking sounds coming from this x-axis, which is this way on this machine, and I thought that I'd lost one of the ball races. I thought I had a broken ball bearing in the in these recirculating linear bearings. So I've taken the what do you call it, the bearing assembly off the end of the shaft and disconnected it from the stepper motor at the other end, so that I can slide the carriage to and fro. That sounds absolutely perfect. The lead screw, absolutely fine. So the only conclusion I came to is the stepper motor at this end, teensy bit of play in the end bearing. I think that might have something to do with it, but more so, there's no mitigation for dust getting in the bearing through here, and there's plenty of dust with this machine. Also, the grease was horrible, so I've cleaned all the grease out, and I might make a shield to go on this side. But first up, I think I'm going to have a look at the bearings and see how they've been overnight in a degreaser. That, I think, is where my noise is coming from. Yeah, I think that bearing has had it. Yeah. Not great either. I don't know if this comes over very well, but this is the stuff that soaked out of those bearings overnight. There's all sorts of crud in there. Right, I don't know if you heard that particularly well, but this bearing is not running at all cleanly. The thrust bearing, on the other hand, absolutely fine. I've got a part number on that one, so that's easy enough, but I'll have to measure this one and see if I can get a replacement. I can't get it out, unfortunately. There's going to have to be a destroy to get it out. I was so impressed with the quality of those bearings, I've been out and bought some new ones. 20 minutes later, I've turned up this dust shield. So this thrust bearing should fit in the end there, like so. And that sandwich should fit in the end of the router. So let's go and try it out. There is the piece I've just turned up, the collar, to prevent dust and stuff from getting in to the bearing. However, when let's just move the camera, when I drive the carriage all the way up to this end, it binds. And let's just put it back the other way. Right, so this is what I think has happened. These holes, 120 degrees apart, weren't drilled on a CNC. They were done by hand, because if you look, they're all at different distances from the edge, and I think that's significant. Also, if I just pull this forward, so if I take the bearing carrier off and the thrust race, then I don't know if you can see that particularly well, but this lead screw was machined down to take these bearings. However, that's a tiny amount of land to hold this bearing absolutely square. As you can see, it's got a little bit of wibbly wobbly, and it doesn't that portion of the shaft should have been a bit, should have been the right diameter to fit that hole. It's okay for this bearing. Very odd. Anyway, however, that bearing, that thrust bearing, as you can see, there's some wear marks on the inside here. It bears on this bearing carrier flange, which is held square because it's bolted to the end of the machine. However, if you can envisage what's going on here, this thrust bearing is only being squashed on one particular point. So as it rotates round, there's only one area that's taking the load, and that, I think, is a bit of a poor design. Having said that, I've used this for at least 5 years without any major problems, except this bearing is gone. So I'm debating whether or not I make a sleeved cap to go over the top here that will hold this end of this thrust bearing square. I need to think about that. This is my solution. I've turned up on the lathe a little stainless steel bush that fits neatly on this lead screw, and because it's supported by the threaded section, if that's the right word, it's quite square, and it's got a recess in this end big enough to take this thrust race, so it's going to prevent the dust from getting in there, and then the outside flange fits on, and Bob's your auntie. However, there's another issue. Let me just show you this. Right, I don't know how this ball screw was machined, but that junction there, as you can see, is not square, and it should be. Let's find a thicker bit. There you go, look. So, I think I'm inclined to take this whole ball screw out, because I don't know if I'm going to lose the balls if I dismantle it. So I think I'm going to take the whole thing out, including the nut, and just see if I can square that up in the lathe. Oh, that was easy enough. Ugh, that needs a clean. I've got the lead screw in the lathe. There you go. There's a bit poking out that end, and it's lightly held in the 3-jaw this side. I've run the ball screw, just snugged it up by finger tightness to the back of the through spindle. Those of you that know the channel will know that I have actually made a tool post grinder, which could do the job here, but I read on the internet that you can actually do this with a sharp insert, and once you're under the plating, you're good to go. So let's have a go. Contact, but I need to go down 2 millimeters. That's one. That's two. Well, I have to say that turned out to be a lot easier than I thought. That was the way it came out. Oh yeah, that's much better. Bearing, thrust race, and that, and there should be just enough room for, there we go. Do you know, I think that'll do. So next up is I need to push this knackered bearing out and put a new one in, and just clean it all up and reassemble it. Okay, I managed to drift out the old bearing. You can actually feel the play in that. That's absolutely knackered. I'm going to, although I've got a new thrust bearing, that one I think is absolutely fine. So all I'm going to do is replace these open cage bearings with these, which are, I can get in. These are ZZs, which are sealed for life with a metal shield. So all I need to do is pop that in there. Okay, one greased thrust race in the hole. Give that a quick wipe. Get the excess off. There we go. That's that. One brand new bearing in there. Well, that runs nice. One, oh, nylock nut. Oh. I need to just get a spanner and get the preload right on that. After a bit of searching, I did find one. Yeah, that's good. I thought I just dismantled this, and I thought I'd just show you this. The ball screw is okay, and the bottom is machined nice, and top is machined nice and square, so that's good. But look at this. That's the top of the thrust race. It never even made any contact. There's still grease on the outside of these balls. This thrust race, this surface, this cage, if you like, whatever it's called, doesn't actually go in the hole. So it never made contact. That's appalling. I'll clean that up and have a closer look, I think. Right, I wasn't going to do this. I was going to just fix these, but when I took this apart, I was so appalled at the design, I thought, I've got to show you and warn other people. So this is the situation. Here's the bearing carrier for the bottom of this. This is the Z-axis lead screw. So it fits like that vertically, and this ball race fits in there like so. Sorry, it goes this way up. Fits in there like so, and this thrust race sits in this cavity. Now, the only thing is that this cavity should retain this thrust race, and as you can see, that is only just supporting it, and it's only supporting that on a burr. So when I saw, when I examined this first off, this bearing race was actually on top, and it's covered in gunk, so you couldn't see it, couldn't read it was a bearing. So I thought that they'd done a good thing here. I thought they'd put a washer over the top to stop bits of dust and sawdust and God knows what falling into the bearing. But in fact, that was the bearing. So this thrust race never had any support whatsoever. So this bearing I'm going to reuse because it's brand new. It's never ever been. There's no wear on it at all because it was never used. Consequently, the bearing at the bottom has taken all the load, and you can't hear this, particularly because there's a jet outside, but this is knackered. So I've had to buy a new one, and I need to modify this. I need to put a plate over here that's going to retain this thrust race. What a crap piece of design. When I cleaned the burrs out of this boss, I saw that there's actually the remnants just in the bottom here of a flange that that clearly should be. Yeah, maybe you can see it a bit better there. There we go, just there. The remains of a flange. So I think what happened was when they assembled this, they didn't make this flange quite big enough, and in doing the nut up on the bottom of the lead screw, they pushed the bearing through the end. So this is my solution. I turned up a flange that fits on the top here that mimics the flange that's been lost. So let me just put the screws in, and we'll try it out. This whole thing is stainless steel, and these are M3 by I think about 6mm stainless countersunk screws. There we go. There we are. I may end up losing 2mm of Z height as we say in the UK, but we'll see. Anyway, there's my new bearing, there's the thingy thrust bearing, so I'll just get this greased up and we'll put it together. Bearing stack in there. There we go. Yep, isn't that is so much smoother than it was. Time to get that reinstalled. There you go, there shouldn't be any play in that whatsoever. So that's another set of bearings that are knackered. Oh, that is smooth. I made myself another sleeve up spacer to protect this thrust race. This is the thrust race that came out, and it doesn't feel too bad. However, I've gone to the cost of putting a new bearing in. So I greased that up off camera because I've got to press record. And this is the axial bearing to go in this housing. So I'll just tap that in. Right, that's that in. That rotates nicely. Let's go and fit it on the actual machine. That's the thrust race and new spacer. It fits on tightly. I realised I actually need a spacer between between that race and the race that's in here, and I'll cut that to exactly the same depth plus 0.1 of a millimetre between these two faces. So there we go, that and that. On with the lock nut. Whoa, oh damn, don't like dropping those. Right, now don't roast me for this, but this is an unused section of that lead screw. Probably a little just to bed it all in. Right, that's so tight it's locked. Ooh. Come back slightly. There we go. Absolutely zero backlash. And I'll bring you in really close so you can see that the thrust race, this end of the thrust race is actually going around. So I'll get the close-up lens. Might not be terribly clear, but just in that gap you should be able to see that the thrust race is rotating as well. So I've got the right tension on it all. There's absolutely zero backlash and it runs really smoothly. Okay. Right. I'm going to go and have a cup of tea while that gets on with this, and just I'll come and have a look at it after it's finished. Finny? Right, change that fan. Would have been easier to start with the door off, wouldn't it? When I first thought about this, I thought I'd punch a load of small holes in the bottom to let the air in. But in all honesty, once the wrong way up, once you've got this pendant in the way, there isn't really a lot of space. So I did this. I 3D printed a grill to go on the front, a Union Jack, in fact, sort of. Yes, Matt, you're right. I do need to put a grill in, and I did find this old grill for a microphone I've got planned to build. So I've nicked that from this from that project even, and I need to just trim it slightly, but that will fit on the front there quite nicely. And I'm just going to mark this out and then drill holes behind it. I'm not going to cut it out completely because I want it to be nice and rigid. And I've never been that keen on these 3D prints. I think they're a bit flimsy. There we go. Here goes. That sounded promising. They're coming out the fans. can feel air moving. Conclusive proof, it works. As I said at the start, this was a long video, so I've broken it into two parts. When I started editing, I didn't realise just how much material I'd actually got, so it was about getting on for an hour and a half. That's too long for anybody. Even my wife can't cope with me for an hour and a half, understandably. So in part two, we will have a look at the bed. I've put a new bed on this old girl, and I think, this is a really bold statement, but you'll have to see what you think when you've seen part two. I think it could be the best bed for a CNC router out there, and money can't buy it. So I do advise you, I encourage you to watch part two. Thanks for joining me. Please hit the like and sub button, and we'll see you in part two, which should be a bit more interesting than part one.